All right, in homework 12.3, we are graphing simple rational functions. All of the functions we're graphing right now are transformations of the parent function y equals 1 over x. If you don't know how to graph 1 over x, this won't go very well, but we should know the parent function looks like this. And it has points here at 1, 1, and -1, -1. And from there, we can do some transformations on it, and it's not too bad. I'm going to do one-to-ones on the front. I think I'll start with number 4, because these have traditionally given some people some trouble in the past. Number 4 is y equals 4 minus 3 over x plus 2. It helps to rewrite this in transformation form, where it's negative 3 over x plus 2 plus 4. Note that the 4 is positive. That negative goes with the 3 over x plus 2. And so this has 3 transformations going on. Right here, what this plus 2 is doing is it's shifting the entire function left by 2. This plus 4 is shifting the entire function up by 4. This negative is multiplying the function by -1, and so it's a reflection. And just to make sure we understand what's going on here, 3 over x plus 2 can be rewritten as 3 times 1 over x plus 2. Because you could put this divided by 1. 3 times 1 is 3. 1 times x plus 2 is x plus 2. You can always take the numerator of a fraction and turn it into a whole number times a 1 as the numerator of the fraction. And so what this 3 is doing is it's a vertical stretch by a factor of 3. Okay, so let's see how this works. We know that in the parent function there are asymptotes at x equals 0 and y equals 0. And when we start graphing this transformation, we want to graph our asymptotes first. So the asymptote shifted up by 4 and left by 2. When you shift up by 4, that takes the horizontal asymptote up by 4. Left by 2 doesn't actually do anything to the horizontal asymptote because it's an infinite line. So just the up by 4. There will be a horizontal asymptote at y equals 4. Left by 2 is going to change where our vertical asymptote is. We go up by 4, which doesn't do anything, and left by 2. So our vertical asymptote will be here. That's actually the answer to part B. The horizontal asymptote is y equals 4. The vertical asymptote is x equals -2. And you can feel free to use HA and VA for short for horizontal asymptotes and vertical asymptotes. Next, we're going to think of what's going on here. Normally, in the parent function, there would be a point at 1, 1. That point at 1, 1 got transformed up to here. It also got reflected across the x-axis. And so that's now going to be below the asymptote. It also got stretched by a factor of 3. That means instead of being 1 away from the asymptote, it's going to be 3 times as far away from where it usually is. So instead of 1 away from the asymptote and down by 1, it'll be 1 away from the asymptote and down by 3. So this point, again, came from this point being reflected to the other side of the asymptote and then stretched by a factor of 3. So instead of being 1, 1 times 3 is 3, so it's 3 away. Note that it is not 3 down from where it was, it is 3 away from the asymptote. From here, I could just follow the points. You know, there's another thing that's going on, which is that this is also a horizontal stretch by a factor of 3. And so instead of being 1, 1, it's 1, 2, 3 away from there as well. So this looks something like that. On the other side, we usually have the point -1, -1. That also got reflected across the x-axis and stretched by a factor of 3, so it'll be 3 up from the asymptote. Also, 3 to the left of the asymptote. So it looks like this. Okay. Let's see, the domain and range. The domain is all the possible x values for this function. And there's a couple ways to do it. One, we can just look at this graph and we can say, well, the only place there isn't an x value is at x equals -2. So all the numbers between -infinity and -2, and then it starts up again and goes from -2 to infinity, but it's not all real numbers because there is no number at -2. The way we write this as an interval notation is the interval from -infinity to -2, union the interval from 2 to infinity. the range, and I'm going to be doing everything in interval notation on this. There are other ways to write this domain also, such as the domain is the set of all real numbers except for the number negative 2. So these are both correct. The range is all the y values, and the y values go down to negative infinity, so we'll have y values at negative infinity all the way up till 4. There is no y value at 4, but then they start up again and they keep going up forever. So the range is all the y values between negative infinity and 4, and then again from 4 to infinity. Okay. The direction. All right, this function is increasing. You read for the direction, you read from left to right. This function is increasing from negative infinity until negative 2, and then it begins increasing again. Remember, we read from left to right, so it's increasing the entire way. So it's increasing on the interval from negative infinity to negative 2, union negative 2 to infinity. It's increasing everywhere in its domain. The concavity, well, it's concave up, bending upwards from negative infinity to negative 2, but then it's bending downwards from negative 2 to infinity. So it's concave up on negative infinity to negative 2, and concave down on negative 2 to infinity. So on the left side of the asymptote, it's bending upwards. On the right side of the asymptote, it's bending downwards. Okay. That's all we're doing on the front. On the back, ooh, I don't know how hard a one I want to do with you guys. I'll do number 3. That seems like a nice medium one. Number 3, we're supposed to use factoring and or long division to simplify and then graph. Well, long division won't work here because x squared won't go into 2x. Like if we set it up, negative 2x plus 8 gets divided by x squared minus 16. Well, x squared doesn't go into this, so it would just be 0 with a remainder of negative 2x plus 8. So it'd be 0 plus negative 2x plus 8 over x squared minus 16. And that's exactly what we started with, except with an extra plus 0, which doesn't do anything. So factoring seems like a good option here. We can factor the numerator because they have a common factor. Whenever a linear factor starts out with a negative coefficient, we should factor out that. So negative 2 times x minus 4 over x minus 4 times x plus 4. And now we can see that this will cancel out, leaving us with a simplified function. However, we have to keep in mind that where we canceled it out, there is a hole. There's a hole at x equals 4. So we can graph this. Let's see, it's shifted left by 4. So there's going to be a vertical asymptote at x equals negative 4. It didn't get shifted up any. There's no plus anything over here. And there's no x's to do long division on. This is just a transformation. So the horizontal asymptote is still going to be at y equals 0. The point 1, 1 gets reflected because of this negative and stretched by a factor of 2, just like we did in the front. And it follows the asymptotes. This point at negative 1, negative 1 gets reflected and stretched by a factor of 2, just like we did on the front. And so that's what our graph looks like. Ooh, and I almost made a mistake. There's a hole at x equals 4. So when it's following the asymptote, but when it gets to 4, it continues on. Now, I didn't ask you to do the domain and the range here, but if I had, the domain is the interval from negative infinity to negative 4, union, there's a break here at the hole. So it goes from negative 4 to 4, union 4 to infinity. Basically, everywhere there are excluded values, at x equals 4 and negative 4, and so those are the things that aren't in the domain. That's why there are these gaps in it. The range goes from negative infinity to wherever this hole is. And what's kind of weird about that is it's very tough to tell exactly what that y value is using the original function. Because you can't plug in 4, you get 0 over 0. But you can use the simplified function to do what we'll refer to as a limit next class. Or maybe we've already done it, I don't know. 4 plus 4 is 8, So we can do h of 4 in the simplified version. H of 4 is negative 2 over 8, which is negative 1/4. And so this point is at 4, negative 1/4. Now it's a whole, and so we know the y value that's missing is negative 1/4. So it's all the y values between negative infinity and negative 1/4, and then all the y values between negative 1/4 and 0, but there's no y value at 0, and then all the y values from 0 to infinity. Now, you did not have to do this on your homework, but I wanted to make sure we at least had an example of it here. Good luck on the rest of your homework.